welcome to this video on the topic of trigonometry. In this video, we're going to unpack the concept of angles of depression. An angle of depression is a convention used for describing a direction, typically downward, relative to a horizontal axis. Looking at the situation drawn below, we have a hand glider looking at a school of fish. The angle at which the hang glider is looking downward towards the fish can be described using an angle of depression. The angle of depression is defined by referencing the horizontal axis as shown by the green line, and then defining the angle of depression as shown by the symbols here. For this, we'll define the angle of depression as either phi or phi, depending on how you want to pronounce it. Now, an angle of depression is slightly different to an angle of elevation. What you're going to notice is that with an angle of depression itself is defined outside the triangle that we use to analyze the situation. So what you can see with an angle of elevation, it is inside the triangle. Angles of depression, it's outside the triangle. To define it as being inside the triangle, then we can use our geometric rule pertaining around alternate angles, which would mean that if this angle over here is phi, then so must this one. Reason for this is the horizontal here and the horizontal here, they're parallel. So what we have over here is a situation that can be described using an angle of depression. Let's see how we can put this to work. A falcon flying 30 meters above the ground spots a snack at an angle of depression of 35 degrees. Determine the direct distance between the falcon and the snack. So what we have over here is a situation where we've got a bird of prey flying 30 meters above the ground, and it can see some sort of animal that it's going to hunt at an angle of depression of 35 degrees. Now, to get into this question, what I always recommend is draw a diagram that's accurate to the description given. Doing this, we have a bird, and what's happening is the bird is flying 30 meters above the ground. So we've got a horizontal there, and we'll say we've got the ground here. Now down on the ground we have some sort of animal, and what's happening is the bird has spotted its food at an angle of depression of 35 degrees, remembering that we're 30 meters high. So what we've gone and done is we've created an illustration to help us unpack the situation described over here. Now, what we're looking for in this particular question is we want to determine the direct distance between the falcon and the snack. So the direct distance shown by this purple line over here. So we want to know, what is this distance? We'll call it little d. Alright, now the next step for solving these sorts of problems is we need to draw a triangle. I'll draw a nice big triangle and then I'm going to annotate it. So we're going to have 35 is on the outside, the right angle is going to fit in here. The quantity that we're trying to solve is for this side over here, and we know this side is 30 meters. If this angle out here is 35 degrees, then that means this angle in here must be 35 degrees due to alternate angles. Now we're going to label the triangle. We're going to use 35 degrees as our angle of interest, theta. And if this is theta, then we're going to find our opposite over here. Opposite the right angle, we have our hypotenuse. This would be the adjacent, however, we're not interested in that today. Alright, so that's step 2 done. We've got our equivalent triangle and we've labeled it. The next step is to list the features and solve. Features we have theta, and that's a value of 35 degrees. The opposite is 30 meters, and h in this case is our unknown, which we've defined as d. So what that means is we have theta, the opposite, the hypotenuse, so we're going to use sine. Writing out the function and ratio, sine theta equals the opposite over the hypotenuse. I'm going to sub in the values, and then I'm going to solve for the unknown. So I need to rearrange this situation. So I want to solve for d, so I'm going to multiply both sides by d. And then I want to isolate d, so I'm going to divide both sides by sine 35. Thus, what I'm going to find is that d is equal to 30 over sine 35 degrees. Now it's at this step where I need my calculator to progress. So I'm going to say up we come, and I'm going to go into run matrix, and I'm going to put in my values. 30 over sine 35. Execute, and it's going to tell me that we get a quantity of 52.30. The units I'm working in is meters, and we went to 2 decimal places. Now looking back at what we were trying to do, we were trying to determine the direct distance between the falcon and the snack. Now the quantity we were given was 52.30 meters. Referencing our triangle over here, what we know is that the hypotenuse must be the longest side within the triangle, and if we're getting a value of, let's say, roughly 52 meters, it's larger than the opposite, which tells us that this is probably the right value. So what we find is that the direct distance between the falcon and the snack is roughly 52.30 meters. Finishing the question off, if we are given a question phrased in English, then the way in which we respond back to it is back in English as well. What we can say to respond to the question is the falcon is 52.30 meters away from its snack, thus concluding this example. So in summary, what we had a look at in this video was we unpacked the idea of angles of depression, we had a look at how to set out a situation involving an angle of depression, and then we had a look at how we can solve a problem. That being, we first draw a diagram that illustrates the situation, we then draw a triangle and label its features, after which we simply just solve it like it's a standard run-of-the-mill trigonometric question, and then we just respond back in English because it was a verbal question.